GPT-5. Is GPT-5 a true upgrade or a rebrand? We will judge it on 5 simple ideas: model selection, hallucination control, sycophancy, safe completion, exception. So first, model selection. What it is? In GPT-5, model selection means matching the right engine to the job. Some models are built for speed, ideal for quick email, short rewrite, small code edits, or simple fact lookups. Others are built on for deep reasoning, better for tasks that need multi-step thinking, careful planning, comparing multiple resources, or using tools like browsing or code execution. The new built-in router in GPT-5 does this automatically. It watches your conversation, sees if the task is simple or complex, and picks either GPT-5 main, the fast one, or GPT-5 thinking, the deep reasoning. It can even learn from hints you give, like saying, think hard about this. If you hit limits, smaller mini versions can take over so your task isn't interrupted. You can still choose manually, either in GPT-5 settings or as developers by directly calling the reasoning model for complex work and the main model for quick jobs. The benefit is that you no longer need to keep switching models yourself. For most users, you just ask your question and GPT-5 makes the choice. But if you want to guide it, you can give cues for more depth or more speed. This way, simple jobs stay fast, complex jobs get thinking time they need, and you avoid wasting time or making preventable mistakes. The second matrix is hallucination. What it is? A hallucination happens when the AI gives an answer that sounds confident but is actually wrong or not based on any information it was given or could retrieve. This is a problem because it makes the models less trustworthy and can lead the mistake in whatever you build or decide based on its answer. Even if the wording feels right, if the fact is made up, it can cause confusion or extra work to verify and fix it. In GPT-5, hallucinations have been reduced compared to earlier versions like GPT-4.1 and GPT-4o. The improvements comes from a mix of better training methods and smarter routing between models. This means it follows instructions more carefully, gives answers that are more factually accurate, especially in real-world tasks like writing, coding, and health-related queries. The goal is for you to get more reliable, grounded responses, so you spend less time double checking or correcting the output. The third matrix is sycophancy. What it is? Sycophancy is when the model simply agrees with what the user says. If the user is clearly wrong, instead of checking the claim or giving the correct information, it echoes back the user's opinion. This creates a big risk in situations where decisions depend on the model's responses because it can reinforce mistakes instead of helping the correct them. GPT-5 has been trained to reduce this behavior compared to earlier models. It is less likely to just say yes and more likely to challenge wrong assumptions, offering a reasoned correction instead. While older versions sometimes mirror user biases, GPT-5 is tuned to give answers that are more careful and reliable, which makes it safer and more useful to decision making. Fourth matrix, safe completion. Safe completion is about guiding the model so that its answer stay helpful without staying into harmful or disallowed content. Instead of just blocking question outright, in earlier models, safety was handled in a much simpler way. When the system detects something that might be harmful, disallowed, or risky, it often reasoned with a hard refusal. This usually meant giving a generic message like I can't help with that or blocking the request entirely, even if the parts of the question were harmless. While this kept things safe, it also created frustration because the model something overblocked. For example, if you ask a sensitive health related question, the model might refuse to answer altogether instead of giving useful, safe guidance. In short, earlier models leaned heavily on blanket refusal as their main safety strategy, which made them less flexible and sometimes less helpful. In GPT-5, every model uses a new approach called safe completion. This model looks at output itself and shape it to be safe and contextual rather than relying only on hard refusal like earlier versions. This results a more balanced system. It avoids harmful responses, but at the same time, it doesn't overblock harmless queries, giving users safer and more practical answers. So the last metric is exceptions. What it means for you in real world apps. Things like timeouts, hitting rate limits, tool errors, or running out of quota can suddenly stop the workflow. For developers, this is a big issue because production systems need to keep working smoothly instead of crashing. When these problems come up, a system that just fails outright creates a poor experience and requires extra manual fixes. But GPT-5 improves this with built-in fallback mini models. When the main model is unavailable due to limits, a smaller version automatically takes over, so the user still gets responses instead of an error. This makes the system more resilient than older versions where developers had to build all the fallbacks themselves, while you should still add retries, timeouts, and guardrails on your end. GPT-5 design now gives you a safety net that makes failure less disruptive. Quick side-by-side comparison: earlier models versus GPT-5. Earlier models required you to pick which version to use, such as GPT-4 or O3, depending on your need. With GPT-5, the decision is handled automatically by built-in router that learns from conversation and choose whether to give you fast response or deeper, more careful one. This means the system adopts in real time instead of leaving the choices fully to you. When it comes to accuracy, older models were generally good, but their performance varied depending on the task. GPT-5 reduces the chances of hallucination and follows instructions more reliably across common use cases like writing, coding, or health queries. In terms of behavior, earlier versions often agreed too easily with what the user said, even when the statement was wrong. GPT-5 is trained avoid that. It is less likely to just echo and more likely to push back with correction and regions. On safety, previous models sometimes blocked requests outright with hard refusal. GPT-5 uses safe completion instead, which allows it to give safer but still useful responses, avoiding unnecessary overblocking. Finally, in terms of reliability, older model could break when you hit users or rate limit, often returning errors. GPT-5 handles this more smoothly by using smaller fallback versions of the model so that experience continues without interruption even when limits are reached. If you are building today, the headline is GPT-5 automates model selection. It's safer and less sycophantic, hallucinate less and fall softer. Under lead concrete improvements over the GPT-4.x and O series. There are for more depth on routing, hallucination reduction, and safe completion, skim the GPT-5 system card and safety post. Thank you so much.